Video is on integration using residues. In today's video, we are going to solve a problem using residue theorem. Now, in this video, we are going to evaluate integral 2z plus 1 whole square by 4z cube plus z into dz, where c is a circle, that is mod z is equal to 1, using residue theorem. So, we have to use residue theorem in order to evaluate integral f of z into dz. So, clearly, what is f of z from this question? So, f of z is nothing but, so this is 2z plus 1 whole square by, this is 4z cube plus z. And now see here, in order to find the residues, what we have to do? So we have to equate the denominator to 0. So after equating the denominator to 0, that is 4z cube plus z is equal to 0. So if I take z common from this will be 4z plus 1 is equal to 0. And see, first thing is, if I equate z is equal to 0, this will be 1 pole, and next one 4z square plus 1 is equal to 0. So this is 4z square is equal to minus 1, and z square value is equal to minus 1 by 4. And see, z can be written as root over minus 1 by 4. So z is equal to root over 1 can be written as I square by 4, and z value here we got as from root, after root, this is plus or minus I by 2. So we got three poles. So one is z is equal to 0, the other one is z is equal to plus I by 2, and next one, this is minus I by 2. And what is our contour, that is mod z is equal to 1 is given. So within the circle we have to find the poles, that is mod z is equal to 1. Clearly mod z is equal to 1 is nothing but mod z minus 0 is equal to 1. So it is a circle with center 0 and radius 1. See, let me explain you this one. See clearly, this is 0, this is 1, this is minus 1. So this is I and this is minus I. So this is a circle with center 0 and radius 1. So among these, so here in between this there is plus I by 2. In between 0 and minus I by 2, this is minus I by 2. Clearly I am showing this one as it is very small. So this is center 0. So this is 1, this is minus 1. So this value is I and this value is minus I. So this is center 0 with radius 1. This is a circle. So in between, so there is 0, there is plus I by 2 and minus I by 2. And therefore all the, see here, all the poles, that is 0, plus I by 2, minus I by 2, 0 are within the circle. So this is the circle. So among these circle, three poles are there. Now we have to find the residues for each and every pole. For finding the residues, see f of z value. So f of z value is clear that this is 2z plus 1 whole square by, this is 4z cube. This is 4z cube plus z. So I am transforming this as, this is 2z plus 1 whole square. So if I take z common, this will be 4z plus 1. So again, this can be written as, f of z can be written as, this is 2z plus 1 whole square by, see this is 4z plus 1 by 2z plus 1 whole square by, this is z, and if I take 4 common here, this will be z square plus 1 by 4. And therefore f of z can be written as, so this value is, f of z can be written as, f of z is equal to, this is 2z plus 1 whole square by, this is 4z into, this can be transformed as z plus I by 2 into z minus I by 2. Clear? So this is of the form a plus b into a minus b. So which is equal to a square. So this is z square, b square, that is I by 2 whole square, that is I square is minus 1. So minus of minus plus 1 and by 2, that is 4. So clearly we got f of z as this one. Now for this function we have to find the pole values. So here there are three pole values. The first pole value is z is equal to 0 and z is equal to plus I by 2 and z is equal to minus I by 2. First of all I am finding the residue at the point z is equal to 0. For finding the residue at point z is equal to 0, here this is limit z tends to 0, this is z minus 0 into f of z. So this value is nothing but limit z tends to 0, z into what is f of z here, this is 2z plus 1 whole square by this is 4z into this is z plus I by 2 into z minus I by 2. Clearly I can cancel this one and substitute 0. So here if it's 0, the value here will be 1. So this is 4 times of this is, if I put 0 here, this will be plus I by 2 and this will be minus I by 2. Clearly, I can cancel these. So after cancelling these, so what remains this one? So this will be minus I square. I square value is again minus 1. So minus of minus plus 1. I got the value as, therefore, residue of f of z at point z is equal to 0 is 1. So we got the residue value as 1 for the pole value z is equal to 0. And the next pole here is z is equal to plus I by 2. So here the value here, the residue value is z is equal to plus I by 2. Here I am finding the residue value, that is residue of f of z at point z is equal to plus I by 2 is nothing but this is limit z tends to I by 2. This is z minus I by 2 into f of z. So what is our f of z value? So this is nothing but limit z tends to, this is I by 2, this is z minus I by 2 into what is f of z here? So f of z is nothing but this is 2z plus 1 whole square by this is 4z into this is z plus I by 2 into this value is z minus I by 2. After noting this f of z value, I can cancel these and substitute I by 2 in place of. So this is I by 2 plus 1 whole square by this is 4 into I by 2. This is I by 2 plus this value is I by 2. After cancelling this one, so this will be I plus 1 whole square. So after cancelling this one, this will be 2I and this is again 2I by 2. And again I can cancel this one. So this can be written as a plus b whole square. So this is nothing but a square plus b square plus 2ab by this is I square is minus 1, this value is minus 2. I square, so here the value is minus 1 plus 1 2I by minus 2. After cancelling these two, the value here is minus I. So this is the residue value of f of z at z is equal to plus I by 2. For plus I by 2, for plus I by 2, the value here is minus I. And the next thing here is we have to find the residue value at z is equal to minus I by 2. So here is the function. For z is equal to, the pole value z is equal to minus I by 2. Now we have to find the residue. So for finding the residue of f of z at point z is equal to minus I by 2. So this will be limit z tends to minus I by 2. This will be minus of minus plus z plus I by 2 into f of z. So clearly what is our f of z value? So f of z value is this one. So this will be limit z tends to minus I by 2. This is z plus I by 2 into this value, that is 2z plus 1 whole square by the value here is 4z into z plus I by 2 into the value here is z minus I by 2. Clearly I can cancel this one and substitute minus I by 2. So this is minus I by 2 in place of z. This will be whole square by 4 times of this is minus I by 2 into the value here is minus I by 2 into minus I by 2. So if I cancel this one, the numerator will be minus I plus 1 whole square by, so if I cancel in two table, this will be minus 2I and this is minus 2I by 2. Again I can cancel this one. So if I expand this one, so this value is a square plus b square minus 2ab by, so minus of minus plus 2 I square, this is minus. So I square value is minus 1 plus 1 minus 2I by minus 2. Minus 2I by minus 2. And therefore if I cancel this one, so minus of minus, so the residue value of f of z at point z is equal to minus I by 2 value is, the residue value is I for minus I by 2. See, Let me check for this one. Residue for plus I by 2. This is minus I by 2. This is 2z plus 1 by this one. After cancelling this one, 2 times of I by 2 plus 1. So this is also 4 into I by 2 plus I by 2. So this is I plus 1 whole square. So this value is 2I into, this is 2I by 2. After cancelling, see here, the value here is, clearly this value is minus I. So this value is plus I. And therefore, we have to use the residue theorem. So what is a residue theorem here? The residue theorem is nothing but, by residue theorem, clearly integral f of z dz is nothing but 2 pi I into sum of the residues of interior poles. So here, our question here, what is our f of z value? So f of z value is nothing but, see, this is our f of z value, that is 2z plus 1 whole square by 4z cube plus z. This is 2z plus 1. This is 2z plus 1 whole square by, this is 4z cube plus z into dz is equal to, this is 2 pi into sum of the residues. The first residue is z is equal to 0. At z is equal to 0, the value here is 1. And for z is equal to I by 2, this is minus 1. And next for minus I by 2, the value here is plus I. So the first value is 1, the next value is minus 1, and the next value is plus 1. After cancelling these two, the value here is 2 pi I. Therefore, integral, integral 2z plus 1 whole square by 4z cube plus z into dz value is nothing but, this is 2 pi I. So this is how we have to solve. This is also so simple, and let me explain you once again. See here, the question is given like this. We have to evaluate integral f of z dz, where c is mod z is equal to 0 using residue theorem. So f of z is given like this. So in order to find the poles, we have to equate the denominator to 0. After equating denominator to 0, z is equal to 0 is one pole, and z is equal to plus or minus I are the next poles. So here 0, minus I by 2, plus I by 2 are within the circle. And if they are within the circle, so we have to transform this f of z as this one. After transforming f of z as this, so we have to use z is equal to 0, z is equal to I by 2, z is equal to minus I by 2 are the poles, and we have to find the corresponding residues. For z is equal to 0, 1 is the, for z is equal to 0 pole, 1 is the residue value. For z is equal to I by 2, minus I is the residue value. And for z is equal to minus I by 2 pole, plus I is the residue value. So according to our residue theorem, so integral f of z dz is nothing but 2 pi I into sum of the residues of the interior poles. That is 2 pi I into 1 minus I plus I, which is equal to 2 pi I is the answer. So this is how we have to solve. This is the most important question. So this is the essay question. Please practice, and definitely you can score more, and pass it on to your friends if you really like. Thank you for staying till the end. Stay connected. So I'll be uploading many more important questions. Please practice, and definitely you will be benefited. Thank you so much.